Gases are one of the fundamental states of matter, alongside solids, liquids, and plasma. They are dependent on the properties of environment, temperature and pressure, and also the internal properties of matter, like composition. States of matter are characterized by their ability to expand and fill any container, their low density compared to liquids and solids, and their ability to flow freely. Unlike solids, gases do not have a fixed shape or volume. Instead, their particles are widely spaced and move rapidly in all directions, resulting in properties such as compressibility, low viscosity, and the ability to mix easily with other gases. Gases play a crucial role in our daily lives and natural processes. The air we breathe is a mixture of gases, primarily nitrogen and oxygen, with smaller amounts of argon, carbon dioxide, and other trace gases. Gases are essential for life processes like photosynthesis in plants and respiration in animals. They also have wide-ranging industrial applications, from fuel gases like natural gas and hydrogen, to industrial gases like oxygen, nitrogen, and helium. The behavior of gases is governed by specific principles described in gas laws, such as Boyle's law, Charles's law, and the ideal gas law. These laws explain the relationships between pressure, volume, temperature, and the amount of gas in a system. Understanding these principles is important in fields ranging from engineering and chemistry to environmental science and medicine. Let's look now. What is pressure? Pressure is a quantity that arises when molecules or atoms hit the container's wall. The more molecules punch the wall, the higher the pressure. Also, the speed of molecules is affecting the force which molecules exert to the container's wall. Average speed is related to the temperature. When there are no molecules nor atoms in the container, it is called a vacuum, and there is no pressure. Where gases are compressible, liquids are not. In liquids, molecules are much closer to each other, and the forces between them are much stronger. Therefore, the pressure rises rapidly when compressed. Inside liquids, the pressure is called hydrostatic pressure, and it arises from the weight of the liquid above. When heat is added to gases, they tend to expand. If this is not possible, the pressure will rise. When gases are allowed to expand, the pressure could stay the same. Intersun. When gases are allowed to expand rapidly, they cool down. If temperature is lower than gases' critical temperature. For hydrogen, this temperature is -80 degrees Celsius. We'll get back to this in the storage course module, but it is just a peculiar property of hydrogen. Let's now look at the basics of how we can calculate the pressure. Pressure is defined as a force exerted onto a surface. So, we can calculate the magnitude by dividing the amount of force by the affected surface area. In the formula, P stands for pressure, F for force, and A for the surface area. Declity, unit of pressure, is pascals, denoted par, in SI units. In practice, amount of pressure is typically around hundreds of thousands of pascals. There are also different units used for pressure, and we'll look these next. As said, there are many different units for pressure. Some units are used more in some parts of the world, and other units more in some other parts. P. Some units are used because of their practicality. For example, a pump's lifting power can be stated in pump's nameplate in meters of water, which is quite practical compared to pascals. So many different units are still in use for pressure. Also, it is good to know that sometimes a G is added to the unit in different measuring devices. This G stands for gauge. It just states that the pressure is in relation to the atmospheric pressure. Depending on how we measure pressure, we can get different value for it. Let's now look what is the difference between static pressure and dynamic pressure. When material flows, it requires a force, and this manifests as pressure too, and is called a dynamic pressure. Dynamic pressure, measured perpendicular to the flow, adds to the static pressure. When we talk about absolute pressure, then the pressure value is compared to a vacuum. Atmospheric pressure means pressure that arises from atmosphere's molecules exerting a force to the Earth's surface. Normal atmospheric pressure is approximately 1013 bars. Pressure difference refers to the difference between two measured values. Overpressure refers to a pressure that is higher than the surrounding or reference pressure, often atmospheric pressure. Underpressure refers to pressure that is lower than the surrounding or reference pressure, often relative to atmospheric pressure. Static pressure means force exerted to vessel's walls by material when at rest or moving towards. Dynamic pressure is the pressure component arising from flow that acts perpendicular to the wall surface. Frullen to the wall surface. Hydrostatic pressure means pressure arising from liquid's own weight. Nominal pressure refers to the standardized pressure level for which a component, system, or device, such as a pipe, valve, or pressure vessel, is designed to operate safely under normal conditions. It is usually given as overpressure in standards. In vacuum technology, it is referred as absolute pressure. Nominal pressure represented as PN, which stands for pressure nominal, followed by a number, indicating the pressure in bars. E.g., PN 16 equals 16 bars nominal pressure.